Hey guys, in this video we're going through Chapter 3 on polynomial and rational functions, and we're going through Section 7 on rational functions. In this video we're doing problem number 29, which says describe the local and end behavior of the function f of x equals 2x squared minus 32 over 6x squared plus 13x minus 5. So when we're looking for the local and end behavior of the function, we want to determine the domain of the function, so all the x values that the function can take and not be undefined. How do we do that? We figure out at which x values the function is undefined. So in order to do that, we have to look at the denominator of this function and find where the denominator equals 0. So to do that, we're going to factor the bottom half of this denominator. So we have 6x squared plus 13x minus 5. And in factoring that, we're going to multiply the first one by the third one and find that we have negative 30. And now what we want to do is find factors of negative 30 that add up to 13. So we've got plus and minus 1 times 30, we've got 2 and 15, and we see that 2 and 15, when you subtract them, we can get 13 from them. So we're going to copy the first term, we get 6x, and then we're going to have 6x here as well, and we're going to have plus 15, and we're going to have a minus 2. And now this is not direct quite yet, because 6x times 6x is going to be 36x squared and not 6x. So before we move on, we have to simplify these and trash out their common factors. So 6 and 15 have a common factor of 3, so we're going to divide 6 by 3 and we get 2x. And we're going to divide 15 by 3 and we're going to get 5. So we have 2x plus 5 times, and then 6x minus 2, find the common factor of 2, divide them both by 2, we get 6 divided by 2 is 3x, 2 divided by 2 is 1. So this right here is going to be our new denominator of the equation. And remember, what we need to do with this is we need to find out where the denominator is going to be equal to 0. So we see we've got 2x plus 5 can be equal to 0, or we have 3x minus 1 can be equal to 0. So from this one we have that x can be equal to negative 5/2, or we have that x is equal to 1/3. Now these are the spots where we will have vertical asymptotes on our graph, because that's where the function is undefined, which means it either approaches positive infinity or negative infinity when x gets to that place. Okay, so now what we need to do, we need to figure out, as for the local behavior, we need to look at x values that approach negative 5/2 and 1/3 from the left and from the right. So first we're going to look at, as x approaches negative 5/2 from the left. So what we're going to do to find that, we're going to choose a number value that is close to negative 5/2, but a little bit less than it. So negative 5/2 is about negative 2.5. So I'm going to look at f of negative 3. And I'm going to plug that into the equation. So we have 2 times negative 3 squared minus 32. And then I'm going to use our factor here, 2 times negative 3 plus 5 times 3 times negative 3 minus 1. And when we figure that out, we have 2 times 9, which is 18 minus 32. Actually, I'm going to go ahead and write that over here. So we've got 2 times 9 minus 32 over, let's see, that's a negative 6 plus 5 times negative 9 minus 1. And you'll see that on the bottom, on the top, we have a negative number. On the bottom, we have a negative times negative, and we're only looking for this one. We're going to look at whether it's going to be positive or negative, because we know as x approaches negative 5/2, it's either going to be negative infinity or positive infinity. So all we need is the sign. So we have a negative over a positive, so negative. So as x approaches negative 5/2 from the left, we have f of x approaches a negative infinity. So that's one of our local behaviors. Now we need to look at x approaches negative 5/2 from the right. So we'll look at, as x approaches negative 5/2 from the right. So like before, we want to look at a value of x that is close to negative 5/2, but actually a little bit greater this time. So remember, negative 5 over 2 is negative 2.5, so I'm going to look at f of negative 2. So we go ahead and plug that into our equation. And we find 2 times 4 minus 32 is going to be 8 minus 32 over negative 4 plus 5 times negative 6 minus 1. Here we've got a negative number over a positive number times a negative number. So here we have a positive. So as x approaches negative 5/2 from the right, we get f of x approaches a positive infinity. Next we want to look at as x approaches the next one, 1/3. 1/3 from the left. So as x approaches 1/3 from the left, we want to look at a value that's going to be a little bit less than 1/3. So we'll look at as f of 0. So f of 0 equals 2 times 0 squared minus 32. All over 2 times 0 is 0, so we'll have 5. And then 3 times 0 is going to be 0 minus 1. So we'll have a negative number over a negative number, which is a positive number. So we'll have f of x approaching a positive infinity as it approaches, as x approaches 1/3 from the left. Finally, we want to look at x as it approaches 1/3 from the right. So we want to pick a number that's a little bit greater than 1/3 to test. So we'll look at f of 1, and we'll find 2 times 1 squared minus 32, all over 2 times 1 plus 5 times 3 times 1 minus 1. And we'll get a negative number over a positive times a positive. So we'll get a negative number. So we'll have as x approaches 1/3 from the right, we'll have f of x approaches a negative infinity. So now we've gone ahead and we found all of our local behaviors. Now what we have left to do is find our end behavior of the graph. And the way we do this is we're going to find the horizontal asymptote to find where the function ends. So to find a horizontal asymptote, we're going to look at the numerator versus the denominator. Now in this problem, we have the degrees of the denominator and the numerator are equal. We have x squared and another x squared. So in order to find the horizontal asymptote, what we're going to do is we're going to take the ratio of the leading terms. So we have a 2 and a 6, and as simple as it is, we're going to have that be our horizontal asymptote at y equals 2/6 or y equals 1/3. So we have that as x approaches infinity. We have f of x approaches 1/3. We also have as x approaches negative infinity, f of x approaches 1/3. And that's our end behavior. Now you'll notice if you look in the back of your book that the answers in the back of the book are different. That's a typo in the book. So these are the correct answers, and I hope that's helpful. I hope you found this video really helpful. The concepts we covered in this video are true no matter what pre-calculus class you take, and the examples I cover are from this textbook right here. And remember, if you're a Baylor student currently enrolled, there is free tutoring on the first floor of Sidrich. You can create a one-on-one appointment online or drop in anytime during our business hours. Please visit our website, www.baylor.edu/tutoring, for more details. Sic 'em Bears.